Welcome back. Today we are going through lesson 13.5, which is all about transformations of sine and cosine functions. So by this point, you should know the parent functions of sine and cosine and kind of what those look like in their graphs. We're going to talk about today is what transformations can happen to that parent function. So you can see that parent function, y equals sine of x and y equals cosine of x. We're going to talk about today is what happens if we multiply by an a value out in front. What happens if we multiply by a b value, and what could happen if we add or subtract a k value at the end of our function. Let's start with the amplitude, the a value. So when we have that a value, the amplitude is always going to be half the distance between the max and min values on our sine and cosine functions. So kind of the peaks to the pits, we're finding half of that value. Our b value that we could multiply helps us find that periods is the horizontal length of each cycle. So the horizontal distance, or kind of what we think of as the x distance that it takes to go through a complete cycle, depending on which sine or cosine curve it is. H value, which I forgot to highlight earlier. So the H value, which is in here with the x, that H value is going to indicate a horizontal shift, which is left if H is less than 0, or right if H is greater than 0. So if it's x minus a number, that's a shift to the right. And if it's x plus a number, that's going to be to the left. All right, the k value. So remember, the k value is the one that we are adding or subtracting at the end. And the value of k indicates a vertical shift if k is greater than 0, or down if k is less than 0. All right, so those are kind of our basics of it. Some other key things we need to remember. We have our midline. So the midline is the horizontal line, y equals k. So we always write it as y equals a number. And that's our midline of our graph. So it goes right through the middle. And then to find our maximums and minimums. So for the sine curve, our maximum is at 1/4 times 2 pi over b for the x value, and then a is the y value. For the cosine, remember the cosine curve is the one that starts up high and goes back down low. So the cosine has two maximum values that we're going to kind of focus on. The first one is at 0a, so whatever that amplitude change might be, that's our maximum. And then the second one, when it comes back and completes a cycle, is at 2 pi over b, and then the y value is a. So notice that no matter which function it is, that y value is a for both of them. And then we're using the b value, which helps with our period length, for the x coordinate. And we have our minimums. So for the sine curve, the minimum is at 3/4 times 2 pi over b for the x coordinate. So again, it's got that b in there. And then it's at negative a for the sine curve, the y value, minimum. All right, and then for the cosine curve, our minimum is going to be at 1/2 times 2 pi over b. So again, using that b value in the minimum to help us figure out where it's at. That negative a is the y coordinate of that. So those are our key points that we're going to use to help us graph with these transformations. So some steps that might help you are listed below there. So the first thing you're going to do is you're going to find your amplitude, your period, your horizontal shift, and your vertical shift. So identifying each of those key numbers that's going on in your equation. Then you're going to draw that midline from the k value. You're going to find your key points, so the points that are on the midline, the maximums and the minimums, and then you're going to sketch your curve through those key points. We're going to practice two of those together here. So here's our first one, example 1 on the next page. For this function, we have 2 times sine theta, or sorry, not sine theta, sine of x minus pi over 2, and then minus 3. So if you remember from our steps on the previous page, the first thing we're going to do is we are going to identify those key values in the equation. So the amplitude, the period, the horizontal shift, and the vertical shift. So for our function here, the amplitude is going to be that a value out in front. So the amplitude comes from that a value, and that number in this case is 2. Our period comes from the b value. Now in this case, we do not have a b value. We don't have any number out in front. So since there is no b value there, the standard period is just 2 pi. All right, then we've got our horizontal and vertical shift. So our horizontal shift here is going to come from the h value. In this case, it is pi over 2. Remember, it's kind of the opposite of what we would think. So it says minus, but that means that the h value itself is positive, pi over 2. And then our vertical shift comes from that k value at the end. So in this case, that vertical shift is going to be negative 3. That k value also tells you where your midline is. So we're going to use that same value for our midline. Remember, midlines are horizontal lines, so we write them as y equals the k value. So I would sketch that on my graph. So I'd go to negative 3 and make a horizontal line. We usually draw it dashed so that we know it's not part of the function itself, but it's a key point on there. So once we know where that midline is, we can start to find those key points that we need. So the first one we know is that our midline point, the first time it hits pi over 2, the first time it hits negative 3 is at pi over 2, and that's because it's shifted right pi over 2. So that horizontal shift helps us determine that our first midline point is at pi over 2 in the midline. And then knowing the period of our sine curve and where it kind of hits things, it's going to go up to its maximum, and then it's going to come back down to the midline at 3 pi over 2. And the midline, which is negative 3. And then it's going to go down to its minimum and go up back to the midline at 5 pi over 2, negative 3. So those would be my midline points. And then I would find my maximum or minimum. So just as a reminder, on that previous page, we can find our max and min for the sine curve using these formulas. So the maximum is 1/4 times 2 pi over b. So let's look at that here. So 1/4 times 2 pi over b. I'm going to write it in here and then I'm going to erase it. So 1/4 times 2 pi over b. When we do that, we get pi over 2. Now remember, we have that horizontal shift still going on. So pi over 2 would be where it is on the parent sign. But now we have to transform it right pi over 2. So if we add pi over 2 to that, we would get a total of pi. So the maximum is at pi. So I'm going to erase that work now. So that one is at pi. And then the maximum on this one, using that a value, so it's got that amplitude of 2 from negative 3. So remember, our midline's at negative 3. Its amplitude goes above that. So from negative 3 up to would be a positive 1. So I have a maximum there. My minimum, so again, remembering from our first page, our minimum, we're going to use that formula, 3/4 times 2 pi over b. So when I do that, that would give me 3 pi over 2. But again, we have to shift it right pi over 2. So when I have 3 pi over 2 and I shift it right pi over 2, I'm at pi. So this one is going to be at pi, or sorry, 2 pi. And then again, since this one's a minimum, from the midline, it's going down to, so from -3, it's going down to -5. So there's a max and min. So when I plot all those and graph them, my graph should look something like this. So I've got those midline points at pi/2 -3, 3 pi/2 -3, and 5 pi/2 -3. And then I have my maximum at pi -1 and my minimum at 2 pi -5. Okay, let's look at the next one. So this one is a cosine curve. So for this cosine curve, we're going to go through that same process. So we're going to identify that amplitude, period, horizontal shift, and vertical shift, and then use them to find my key points. So I have my amplitude here is 1/2. Remember, the amplitude is always that A value. This one does have a B value. It has a B value of 2. So that's going to help me identify the period. So remember, standard period is 2. When we have that B value of 2, that changes that period to just pi. So 2 pi over that B value, that's going to give me just pi. Then I have a horizontal shift. In this one, I don't have a horizontal shift at all. There's no H value in there with the X. So we would just say there is none. And then I do have a vertical shift up here in the K value. So that would be at -2 or down 2. That would be at -2. So that makes my midline y equals -2. So again, that's that dashed line across my graph horizontally at -2. All right, my midline points for this one. So knowing that my standard graph, a cosine curve would hit the midline at pi/2, but remember this period is shrunk. So that means that my midline for this cosine curve is going to be at pi/4, and on the midline of -2. And then the next place it's going to hit it is 3 pi/4, -2. And again, that's because it's condensed from a 2 pi period length to a pi period length. So it's shortening everything. All right, and then lastly, we need my max and min. So using those formulas again from the first page for my cosine curve, the cosine maximum is going to be at 0a, but our maximum is still going to be at 0, that kind of starting point. But I do have a vertical shift down 2. So with that vertical shift, it would move down 2. So it would be at -1. And then remember, this amplitude is only a half. So it's only a half above that midline. So it would be at -3. I would also have a maximum at the end of the period. So that would be at pi. And it would also be at -3/2. And then, of course, I need a minimum in between those. So that would be at pi/2. And it would be at -5/2 because it's a half below midline. So when I plot all those, my cosine curve with this equation would look like this. Okay, so that's kind of putting it all together. We're going to look a little more in depth at those transformations that are going on here. So using our note catchers here, we're going to look at the sine function first. So these are transformations just of our sine function. So we have two types of transformations that we're going to break down. So the first one is dilations. So there are 2 ways to dilate. We could change the amplitude, which is where that A value changes. So that changes the amplitude. Other transformation we can have there is when we have a B value. So remember, the B value is right in front of the X. It's being multiplied. So when that B value changes, it changes our period. And so the amplitude changing is where it gets taller or shorter, the curve does. So in this case, we have a stretch by a factor of 2. So that means that I would multiply by a 2 out in front of my sine of x, and therefore my amplitude would be 2. I can also shrink it a little bit here. So for a compression, that a value is between 0 and 1. So in this case, it says a compression by a factor of 1/3. So I would have 1/3 of sine x. And so the amplitude would only be 1/3 above and below the midline. When we change the period, remember that stretches it or compresses it horizontally. So for a horizontal stretch, if we have a factor of 1/2, that means that my equation would look like sine of 1/2 of x. And then my period would then get stretched out from 2 pi to 4 pi. So we would take that 2 pi, that's a standard period, divide it by 1/2, and that would give me 4 pi. If we want to horizontally compress it, so make the period shorter, we would multiply by a number that's bigger than 1. So in this case, it's a factor of 4. So my equation would look like sine of 4 of x. And my period on this one would go from 2 pi to pi over 2. So remember, that's coming from 2 pi, the standard period, and dividing it by that p-value. All right, so let's look at 2 other transformations that can happen. So we've talked about our dilations. The next one is translations. So these translations come from 2 different values going on. So we have our k value. That is going to be a shift up or down. And we have our h value, which is inside with x. That's going to shift it left or right. So let's look at our vertical shifts first. If I want to translate it up 3 units, I would take my parent function and I would add however much I want it to move up. If I want it to move down, so in this case down 1 unit, I would take my parent function and I would subtract however many units down I want it to go. For horizontal, it's going to look similar, except now it's affecting the x values. So if I want it to go left pi from the parent function, I would take the sine of x, and then if I want it to go left, then it's going to be plus pi, because it's going to be minus a negative pi to go left. And then if I want it to go right, pi over 2 in this example, I would take the sine of x and I would subtract positive pi over 2 to go right. So those are the transformations of the sine function. Let's go through the cosine now. So these are going to be our transformations of our cosine function. So we know what the parent function looks like. Let's go through those same transformations. We can still change the amplitude by multiplying by a value greater than 1. When we multiply by a value greater than 1, it's going to result in a vertical stretch. So for our cosine function here, if we want to stretch it by a factor of 3, I would write that as 3 times cosine x, and my amplitude would now be 3. If I wanted to compress it, so make it a flatter curve, in this case I want a factor of 1/4, so it would be 1/4 cosine x, and so my amplitude would only be 1/4 above and below that midline. All right, let's look at horizontally stretching and compressing now. So that horizontal stretch and compression comes from changing the period with the b value. So if the b value is a fraction, it's going to stretch it by a factor of 1/3. So if I take my cosine function and I multiply it by 1/3 x, that's going to take my period from 2 pi, which is standard. If I divide it by that 1/3, I get 6 pi. So now it's stretching it horizontally out to 6 pi to complete a whole cycle. If I want to do the opposite of that and do a compression, then I'm going to multiply it by a factor bigger than 1. So in this case, 2. So that would look like cosine of 2x. And that means that my period of 2 pi is now becoming a period of pi. All right, then we have our translations. So our shift up and down, that comes from that k value. And our horizontal is going to come from the h value inside the parentheses with the x. So let's take a look at a few examples of those. So in this one, we want to shift it up 1 unit. So I am going to take my cosine of x, and I am just going to add 1 on the end. That shifts everything up 1. If I want to translate it down, so in this case down 4 units, we're going to take the cosine of x and subtract 4 to make it go down. If we want to move it left or right, it's going to be kind of the opposite of what we think. So in this case, if I want to go left pi over 2, I'm going to write it as cosine of x minus a negative pi over 4, which we write as plus pi over 4. And if we want it to go right, then we are going to subtract positive pi. So it's going to look like cosine of x minus pi. So those are all the transformations of sine and cosine functions. We'll see you next time.